Okay, good morning. So how is everyone? So I heard that some of you were working hard yesterday evening rather than having parties or going for sightseeing. So this is good. Today I'm going to talk for 1 hour, and then there will be a representative of Google here, and after that a representative of Estonia in Silicon Valley, Mr. Andrus Virg, and this will be followed by lunch, and after lunch you will have the head of Skype Estonia talking to you. As you remember, we promised a visit to the development center of Skype, which is next door to TTU, but unfortunately they couldn't take as large group, but I think what they offered is even better, that the boss himself is coming here to talk to you and take your questions. So I think there are all reasons to be happy about it. This morning I'm going to talk about knowledge needed in your system. I'm starting from a bit further away. There is really nothing new in this world. So in some ways all things have already been discovered, and it all goes back to ancient times, to Bible and so on. And the same is also true for modeling, designing socio-technical systems as software-intensive products. So the universal principle we have applied here is nothing but conquer and divide principle, which means that having a complicated problem like most of you or all of you actually are trying to address with your products, the only way to solve that problem in a reasonable way and to offer something to your customers is to divide that complicated problem into subparts that are manageable, because complicated problems as integrated or as wholes are not manageable, but the only way to deal with them is to divide them into manageable subparts. And this is what we have been doing. So we represent the essence of that complicated problem as the purpose in the goal model, and then we divide that purpose, the main goal, into sub-goals, and each sub-goal represents one aspect of that complicated problem that you are trying to solve. And yesterday you saw that we are actually doing the same with the solution, because we also divided the solution between different software entities, agents, software agents, and also humans that we also call agents. So we are talking about software agents and human agents, and we divide the solution between them. In other words, rather than having the one platform or one system that solves your problem, we should actually think about subparts or functional units of that platform or system that together solve the problem. And here it is not important if your problem is a distributed one or more a centralized one. I think always this even a centralized solution should be divided into functional units. I mean centralized in the sense that it will not be deployed on the internet in a distributed way in different locations, but it will be deployed as a web service or as a web page. Even then you should think about functional units, functional subparts of the overall system. And this is why this approach of mapping roles to types of agents, both human agents and software agents, is useful, because it forces you to think in this direction, in the direction of dividing your solution into functional subparts. And important is that it's not just dividing in a mechanical way, but all of such subparts, all of such agents make sense. So such a subpart functional unit would be coherent. And actually, maybe one aspect that I didn't well explain here is that when we take our goal models, well, we represent the purpose of the system and start dividing the purpose into sub-goals. And actually, when we continue doing so, when we continue elaborating sub-goals, so we go further down and down in like a spider way. So starting with the root of the tree and then elaborating the tree, go further down. Then at some point we reach the level when those goals can be achieved by individual agents, be it human agents or software agents or pieces of code, as we can also define software agent, coherent pieces of code. So this is the link between analysis that we addressed on Monday and Tuesday and design that I'm talking about now and that I started already yesterday. So we elaborate our goals until we reach the level where those goals can be achieved by individuals, either software units or humans, and then we can actually map our roles that we also have attached to goal models to those individuals. And then after that, then we can map acquaintances between these units, humans and software agents, and based on these acquaintances we can design interactions between them. Okay, so that I won't forget, the slides for today's lecture are already available online, so you will need them in the afternoon when we're getting to our practical exercise. So this is the web spot where you can find the slides. So I think I already did the introduction. So and I started actually even from analysis, even from goal models. But yesterday we were learning about deciding the types of agents and modeling acquaintances between them, and then there was a lecture on modeling interactions between agents. So today I'm going to talk about knowledge, because in each system, in any kind of system, you need to represent some knowledge about people, about products, about environment, the knowledge about actually the system itself, the kind of more technical kind of knowledge. So we always need to represent knowledge. And now when I'm talking about knowledge, I'm referring to a more kind of a statical kind of knowledge, because you know that knowledge, there are different kinds of knowledge. For example, there can be some sort of procedure or algorithm as a knowledge, and it is also a piece of knowledge. But here I'm talking about the knowledge that can be represented in the form of domain entities, like for example quote, request for quote, order, patient, pregnancy, insurance coverage, well, restaurant, for example. Restaurant was in one of the case studies, it was a role, but we also need to represent knowledge about restaurants, because each restaurant is characterized by its name to start with, its location, its kind of specialties. It specialized in Chinese food or Irish food perhaps, or Estonian food. So in many cases, actually, the names of roles and knowledge entities overlap because they are about different things. The role is a model in terms of responsibilities, and the knowledge, but the domain entity, the unit of knowledge, this just represents what we need to know about that particular entity in our system. And I will bring examples. So this is where we are in terms of the viewpoint framework. So we are doing design, and yesterday we covered, we actually addressed how to map roles to types of agents. Then we also treated acquaintance models and interaction models, and now we are talking about knowledge models for our agents. And with the knowledge, you may now ask, what is the difference between the domain model I actually discussed on Tuesday and the knowledge model? So this is the domain model. You remember the domain model for the case study of Tamagotchis. So the domain model represents the units of knowledge called domain entities for the system as a whole. So here we are not so much concerned what each individual component, individual agent in the system knows about, but we are concerned what kind of knowledge should be represented in our system. And in the case study of Tamagotchis, so one piece of knowledge that needs to be represented is present, because a Tamagotchi should be aware of the presence that it has to give away to other Tamagotchis. So this is just one example. Of course, there are many other items that a Tamagotchi has to be aware of, like items of food and different toys, and also has to keep track of its friends and so on. But one example is present. And in the domain model, in addition to representing domain entities, these units of knowledge, like present here, we also represent how they relate to roles. So here we are talking about domain entities and roles, rather than about agents and their knowledge items, like we do in agent knowledge models. And also there is an option to represent here environments, like Tamagotchi shell. You remember that local environment, the box where your digital pet lives in, and Tamagotchi town, the global environment on the internet where you can enter with your digital pet. So this is about a domain model for the case study of Tamagotchis. So we also had a domain model for grocery shopping, and the domain entities here were shopping list, shopping basket, product information, store location, and fuel cost. And in the middle is the role of assistant, and we also show here how the role relates to different domain entities. Like, for example, the assistant considers shopping list by the customer. The customer, I mean the human playing the role of customer, has created the shopping list because no one else can do it. The assistant can help with it, but the assistant cannot create the shopping list in place of the customer. Assistant creates a shopping basket for each individual store to be visited based on the shopping list by the customer. And when doing so, the assistant considers the fuel cost and considers store location. Actually, in the other way around. Considers store location, and based on that, considers fuel cost and calculates the overall price. That includes the prices for groceries as well as the price for fuel. So this is the domain model. Again, our focus is the system as a whole. So we are not concerned with individual parts of the system, individual agents here. Here is the more complicated form of this domain model. So it has many more domain entities represented for the system of grocery shopping, like, for example, route and product information, also customer preferences, customer location, because a customer may have specific preferences that I would like to visit those and those stores, even though the prices at other stores might be cheaper, might be lower, but still a customer may have her or his own preferences. So it is just a more complicated form of the domain model that you saw on the previous slide. And just like the other domain model, it also shows how roles are related to domain entities. But there are just more roles, there are just more domain entities, there are more relationships between roles and domain entities. And now, with this background, we can now easily talk about agent knowledge models. Because what we did yesterday, or what you did actually, well, you divided your solution into types of agents, both human agents and software agents. Even if they will not be implemented as software agents in the classical sense, in the artificial intelligence sense where they actually originate, even then we can use the term software agent, because as I mentioned yesterday, it is so universal. It entails both reactivity and proactivity, and social behavior as well. So agent knowledge model is nothing but elaboration of a domain model, and it represents the knowledge that agents have about their environments, about themselves. So now we talk about the knowledge by agents, rather than talking about knowledge represented for the system as a whole. So now we're interested what each agent knows. Like we here, we can be modeled as agents. So each of us knows something private that no other agent knows. Each of us has some selective knowledge that only our friends know, that only our people in our circle of trust know. Like there was I actually like that circle of trust notion in one of the case studies. And there is also some shared or public knowledge that we share with everyone else. And as an example of the shared knowledge is actually what I'm talking now, that this is shared knowledge. I mean, of course, you pick up different things from this knowledge, but basically that knowledge that I'm trying to transfer you, I mean, is a shared knowledge between us. And now there is a term ontology. So have you come across the term ontology before? Can you raise your hand, those who have actually, who are familiar with this term, ontology? 1, 2, 3, 4 or so. So not too many people. Yes, well, ontology, there are two meanings of the word, of this word. So one meaning is that ontology is a kind of attempt to describe the world around us as adequately as possible. So an attempt to actually create precise descriptions of the world in terms of models. For example, it is about analyzing different objects in the world, how they can be categorized into active objects and passive objects, like active objects as agents, passive objects as objects like this stand here. Then also about activities performed by active objects or agents, how these activities, what kinds of activities are there, how they can be divided into atomic parts, actions, and so on. So it's rather philosophical. It's a kind of attempt to describe everything in the world in detail. And of course it's always biased in the sense that I don't think it's ever possible to do it in an objective way, because there are so many possible ways to do it, but still it is worthwhile to take this kind of attempt, even a partial attempt to describe the world. The other meaning is ontology as a common framework of knowledge, and this is the meaning that we are interested in here in the context of our course. So ontology means that we have a common understanding of phenomena or of objects. So it is about meaning, it is about semantics. For example, as humans we can interact only because we have a common understanding of the environment around us. So we all, for example, we all know, what is this wall, what is the meaning of a wall here, the ceiling here, this screen here, the microphone. So we all know the semantics. Well, it is not well defined, but we all understand, and we all know what it means to attend a summer school, what it means to listen to a lecture, what it means to do a practical exercise. So this is actually an ontology. Well, you might say it's self-evident, but not always, because when you actually visit other countries, then you see that in other cultures things might be different, and there might be things that you do not understand without knowing about these things. And in such a case, you may easily enter a situation where there is no common ontology between you and other people, and it is hard to interact with these other people. And this is not just about language. That is one thing, that there may not be common language, but even if you have a common language, you may not have a common semantics, common understanding of the things around you. And a good example is from science fiction. If you go to another planet, and even if you manage somehow to communicate with these people, even by mind reading, for example, it's still impossible to understand, because their world is their understanding of the world is totally different. They have different notions, also different laws governing their world. So this is the meaning of ontology. And now when we are designing socio-technical systems, and especially when we're designing the artificial parts or technical parts of those systems, we should consider this ontology, because it is very important for software agents or software units to understand each other. Otherwise, our system simply would not work if the different parts would not understand each other. So this is the meaning of ontology in the sense of a common framework of knowledge. And how do we do it? So how do we represent such ontologies? So there are two kinds of knowledge items that need to be represented, knowledge items for agents. So first of all, there are knowledge items that are called knowledge attributes. And knowledge attributes, they characterize agents themselves. So they are about information concerning agents. Like, for example, for Tamagotchis, there are knowledge attributes like Tamagotchi name, represented as a variable of the type string. So now I'm getting technical here, talking about already variables, variable types. There is Tamagotchi age, represented as a variable of the type integer. There is Tamagotchi gender, represented as an enumeration with the two possible values. So enumeration means that this variable here can have either value m male or value f female. So this is the meaning of enumeration. Tamagotchi generation. So what is the generation of Tamagotchis that you have hatched with your Tamagotchi toy? Because you can, because the Tamagotchis have life cycles. They die, they grow, live and die. I mean, they are born, they grow, live and die at the end, like humans. So that's why there is a variable for Tamagotchi generation, Tamagotchi weight, Tamagotchi hunger level, Tamagotchi happiness level. Those change all the time according to some algorithm, of course, that is known only by the creators of the Tamagotchi toy. Tamagotchi training level, and this is related to discipline in your Tamagotchi. If the training level is low, the Tamagotchi is naughty, and you need to discipline it in order to increase the training level. Tamagotchi life points and Tamagotchi gotchi points that are used for by Tamagotchi for paying about things when it goes to Tamagotchi town, the global environment. Then it uses gotchi points for paying to go to movies, for example, or to go to King's Castle and so on. So knowledge attributes, they intimately characterize agents. Like each of us is characterized by certain strategic measurements like height and weight and so on. In the same way, when we design our systems, then our software entities, they also may be described by some intrinsic knowledge attributes. So another example is here, and this is now both about private knowledge by Tamagotchis as well as about shared knowledge. So here we have got this Tamagotchi playing the role of my Tamagotchi. So this notation is about, what it means is that it is an agent of the type Tamagotchi, but in addition we represent here the role it plays, because in some cases it makes actually our models clearer, that we represent also the role along with the type of our agent. Tamagotchi playing the role of my Tamagotchi, and here is Tamagotchi playing the role of a friend Tamagotchi. Now let's focus on this Tamagotchi first here. Well, what is its private knowledge? Well, it knows about its owner. Well, sure, Tamagotchi needs to know about its owner. And the knowledge about owner, and this is now the conceptual object representing a conceptual object type representing the knowledge of representing a part of the knowledge by Tamagotchi. The knowledge about owner is characterized by its name and its birthday. So the Tamagotchi should know about the name of its owner, the name of the child playing with it, and should also know about the birthday of the child. So why should it know about the birthday? Any ideas?
He knows age, and he knows only to congratulate on birthday day.
Yes, exactly. So that it can congratulate its owner on the owner's birthday. Yeah, exactly. So and this is another example of proactive behavior. That okay, I'm the owner of Tamagotchi, and I have birthday, and all of a sudden my digital bed makes a noise like beep, and then I actually pay attention to that, and then it congratulates me and offers me a flower, virtual flower. So this is a kind of nice, isn't it? And it is proactive behavior. Even if it is, we know it is based on some predefined algorithms that prescribe the behavior by Tamagotchi, but even then, it can be described as a proactive behavior. Then Tamagotchi knows about its friends. And this is also private knowledge. So this was private, and the knowledge about friends is private. And each friend is characterized by name, by gender, and by level of friendship. And gender is important because the Tamagotchis can marry each other, so gender is important. And level of friendship is also important because only the Tamagotchis, two Tamagotchis of the opposite gender, who have become really good friends, whose level of friendship has actually increased to really, I think it was named something like heart friend or something like that. So only those Tamagotchis can consider marrying each other. So this is why there's gender and level are important. So the private knowledge is here. Now another part is shared knowledge. And the shared knowledge, one piece of shared knowledge, one object type for shared knowledge is present. And well, why is it needed? Why does it need to be shared? So here is my Tamagotchi, and there is friend Tamagotchi. So why do they both need to know about presents? I think it is self-evident because interaction, because now and then one Tamagotchi gives a present to another one, and then they both need to be aware of the concept of present, and they need to be aware of different kinds of presents, like shown here, some item or some snack. Item is like a toy, snack is something that can be eaten. Of course, it's all virtual, but it is a simulation, but well, we still need this kind of categorization. And this is what is done in ontologies also. In ontologies, we also represent what subtypes of items are there. So this is a very important part of any ontology. So this is an example of shared knowledge present. Of course, there is a lot more about shared knowledge. They need to be, if two Tamagotchis are to play a game together, they need to have a shared knowledge, joint knowledge about the game they're going to play. So if they're going to eat somewhere out together, I mean, in the Tamagotchi town, for example, they need to have a common understanding of the kinds of foods that are available there. There is one more thing about private knowledge, and it is this password here. And the password, this is an interesting thing, because you know this Tamagotchi shell that cover, I mean that kind of colorful thing, the local environment for Tamagotchi, that can generate unique alphanumeric codes, passwords. And with this kind of code, I mean, you can enter the Tamagotchi town, and there your digital pet will be uniquely identified, meaning that its name is known, I mean, its gender is known, its friends are known, and there it can wander around in that virtual environment, Tamagotchi town. It can meet other Tamagotchis, it can become friends with them, but it can also do shopping, and then its Gotchi points are reduced, but it can also earn Gotchi points by, I think, even by kind of gambling, I think, in the Tamagotchi town. So this is why this Tamagotchi town, the virtual environment, needs knowledge about this Tamagotchi who actually sits in my local environment in that box. So this is why it is important. We need to transfer that knowledge somehow to the virtual environment. So that is about transferring knowledge between two environments, local environment on one hand and global environment on the other hand. And here it is done by means of an alphanumeric code that encodes all that information. It's quite a long code, I think at least 10 digits, and that it somehow encodes all the information required. Of course, there can be more sophisticated ways of doing that, but with Tamagotchis it is done this way. I don't know, I'm not aware of the actually newest generation of Tamagotchis. Maybe now it is done differently. And this means that my Tamagotchi needs to know about passwords, but the passwords are shared between two environments, between Tamagotchi shell and Tamagotchi town. And actually it also works in the other direction. Then when I exit Tamagotchi town, then a password alphanumeric code is generated by Tamagotchi town, and then I enter that code into the Tamagotchi shell, and in this way I can transfer knowledge back from Tamagotchi town to Tamagotchi shell. And then this kind of knowledge reflects, for example, if my Tamagotchi has attended school, or has bought something, or has visited the king's castle, and other possible activities in the Tamagotchi town. So this is a partial knowledge model of a Tamagotchi. And as another example, here is the knowledge model for grocery shopping. And this is a simpler version of a knowledge model represented as a table. And this is what I will ask you to do today, later on, when we have a time for exercise from 2 to 3. Then, I mean, this will be our exercise actually to do this kind of knowledge model for your product ideas. So what we see here? Well, there are, first of all, we see agent types, shopbot and a coordinator agent. And now we represent their private knowledge. And private knowledge is in the intersection of two shopbot, actually in the intersection of the row for shopbot and column for shopbot. So this is the private knowledge by shopbot. Shopping list, shopping basket, customer location, and route. So, and shopbot, I think you probably remember that the shopbot is the software agent that helps customer with shopping. And we also had another agent, coordinator agent, in that system. And obviously, in this kind of system, some knowledge needs to be shared between shopbot, the customer's agent, and the global coordinator agent. And this knowledge shared between them is represented here. Product information, store information. They both need to know about products, about specific information concerning that product. They need to know about stores, including the location of that particular store, and the name of the store, the kind of specialty of the store, and so on. So very simple way how to represent shared knowledge and private knowledge, just by using a table of this kind. Okay, but now, as we actually are planning to do the exercise only in the afternoon, so I would like to ask the different groups here representing different product ideas about what kind of knowledge should be represented in your system. I mean, just name some knowledge entities that you think are appropriate for your system. And it's not, I'm not asking about how they relate to specific agents, but just what kinds of knowledge needs to be represented.
For us, it's,
yep.
For example, environment around the house or inside the house, temperature, pressure, I don't know, the day of the week.
Yep. Yeah, environment is very important, yes. Yes.
Right.
Yes, and temperature, pressure, so this is about weather, I mean, like environment.
Inside
like
and outside, usually, for example, you have also weather stations that measure the humidity and the temperature inside the house and outside. So you know the difference.
Yes,
the difference is important.
Yes. So you need information about both external environment as well as a local environment inside the house, because you need to give the balance somehow. Yes, so when it's hot outside, you need to go cool, and when it's cold, then you need to warm the house, and all automatically without an interruption by humans.
Right.
Yes, and okay, and then there's something else you mentioned, environment and.
It's a lot actually. We also need to control devices. So for every specific device, we'll have the list of its own parameters.
Yep.
I don't know, the water pump, for example, pressure in the system that generates to put the water on the tubes. So you need to know what is, again, the pressure.
Yes, and you need to represent the profiles of owners, or the owner profile, but also the profiles of other people living in the house. This is also important. Yep, good. Yes, thank you. So what about other product ideas?
In our system, if we'll talk about the main entities, we will have restaurant profile as a main.
Yes.
And under restaurant, there will be menu food.
Yes.
And beside, in the customer side, the customer has a profile as well.
Yes.
Like name, gender.
Yes.
Address.
Yes. Preferences, food preferences, allergies. Yes.
Or interest, like what kind of food he likes.
Yes, like Chinese or Indonesian or whatever. Yes. Yep. Yes, good. Thank you. So. So what about other groups? Yeah.
I think maybe ours is user information, friends, the name of the user, age, and so on. Also, how the user has acted in the social network before, how he has rated other friends and so on.
Yeah. Yes. So you need to represent that information, and then you need to come up with appropriate knowledge entities for doing it. I mean, you need to structure that information. Yes. Yeah, because it's all about actually experiences by different users. Yes. Okay. Good. So what about the group here?
Well, for our the number of events, probably how many people are going to attend, also the trustworthiness of the person.
Yes.
There's
Yes.
the rate
Yes.
or
Yes.
how many times the person has created an event, how many times people
Yes.
have rated it high. All that's going to
Yes.
go under the statistics.
Yes. So this means it is about persons. It's actually a profile of a person.
And also the events
And event. Yeah, the two things. Profiles of.
And also the person, they can create a group.
Yes.
Specific group.
Yes. Then persons, their profiles, events. These different attributes that characterize events, and the groups also. I mean, and the groups are characterized in terms of probably their common interest, and of course members, which means that there should be a relationship between the group and the domain entity describing a person, because you need to know, I mean, who belong to one or another group. Yes. Okay. Good. Thank you. There's no one here. No? So, what about this benefactory?
Yeah, I think we have knowledge about the intermediator.
Yeah.
And his friends. The knowledge about the intermediator's points.
Yep.
Knowledge about the votes.
Mm-hmm.
The project.
Yeah. Yes.
Knowledge about total points.
Yes. Then I think now this actually comes nicely together with these types of agents you identified yesterday, because, well, you mentioned knowledge about points, and then I think there was one agent that was actually assigned for the point counting or keeping track of the points. So that probably will be the knowledge about points will be a private knowledge of that agent, and then also the other knowledge entities you mentioned also relate to different types of agents. Yes, good, thank you. So we always need to consider knowledge to be represented by our system, because this is a very essential part of any system, be it a centralized system or a distributed system. And I'm glad that you came up with good ideas for what kind of knowledge needs to be represented. The practical exercise for this afternoon is described here, and it is actually what we started now. It is about deciding the domain entities, like modular units of knowledge for the product idea of your team at first. So why did I include this? The first item here is because, you know, on Tuesday we didn't have too much time to spend on domain models. And domain models, they deal with representing knowledge for the system as a whole. And as we didn't have too much time, not too many of you actually created domain models. And now I would like to come back to this because knowledge models, which is the topic for today, they are rooted in domain models. And I would like you to think about domain models first, and then only then about knowledge models that represent knowledge by different types of agents. But you do not need to create the full domain model, but just first of all, just list the domain entities, like modular units of knowledge about your system, pretty much in the way you did already now. But then you will have more time, and then you can think more thoroughly, and you can also then try to somehow categorize this knowledge or these pieces of knowledge you mentioned as domain entities. Because, as for example, you mentioned about the information about environment, both the local environment and outside, but in the afternoon, then you will have an opportunity to think about what entities of knowledge are required for that. For example, that there could be one entity called external environment information, and then this external environment is characterized by like humidity and temperature and wind and so on. So that is one option, but you may well divide it into several entities. So there could be one for wind, one for humidity, one for temperature, including the changes in temperature. So it's up to you. It's actually it's an important decision to be made, because the information processing in the system depends on that decision. Then after that, I will ask you to relate these domain entities to agent types, either graphically or in a table. So please pay attention to agent types, because yesterday you already decided agent types. So you already divided your solution into functional subparts. And now I'm asking you to relate these domain entities that you have listed here to agent types. Graphically, like here, for example. Of course, your model doesn't need to be that complicated, and you do not need to include as many details, but this is just gives you a basic idea how it could be done. Or another method of doing it is as a table, like here, just showing, I mean, just showing for each agent type what are its private knowledge entities, like here for ShopBot, the private knowledge entities are here, and also showing what are shared entities between between agents of different types, like shared entities between agents of ShopBot and coordinator agent are product information and store information. So it's up to you, I mean, how you do it, as a kind of free form figure or as a table. And then also, time allowing, you can continue working on your other models, like a goal model, role models, organization model, agent acquaintance model, and interaction models. So as we have, I think, a bit, yes, actually it's a proper time to take questions, yes?
Maybe it's a bit strange question, but
yeah, no, that.
What is the reason to divide actually the knowledge into internal and then external? I will make an example why this question came into my mind. For example, the human being. Nowadays we know that we are very complicated. We can measure not just weight. We don't have only just names, but we know we consist of DNA and so on. But many thousand years ago, probably people even don't know the name of each other, and so their behavior was concerning the knowledge of themselves at that time. So what do I think that actually it's the important is for the agent is not the internal data, but like identifying itself who it is, and the data should be somewhere outside. As soon as it grows, this outside data, for example, Tamagotchi knows that just one thing, that it is a Tamagotchi, and the knowledge and behavior is somewhere outside him, and this domain can be growing, and Tamagotchi may, how to say, know more about itself, and It's not like encapsulated in
yes. Well, with humans, it is it is usually inside, right? But of course, I mean, I think for some strange reason, we actually tend to outsource a lot of that information in social networking services like Facebook. This somehow actually sounds similar to what you are saying. That somehow, I mean, I have my private knowledge, but I actually it's open. Yes, I actually include even some of my private knowledge in Facebook, and then I can I can share it or not. But even if I do not share it, then it's still not private knowledge anymore, because I mean someone is able to read it. I mean anyway. I mean I don't believe in this. I mean total like honesty of the Facebook employees that are managers. So I mean they do it. I mean even for if for nothing else than for advertising. So to find I mean what people are interested in. Maybe not specifically. I think you can turn off that direct advertising. But in general, I mean they have a lot of information about interests by different people, and then they analyze that information, do some data mining, and then they get an idea, and then they can offer that processed information to companies. So I think this is the way it works. But it's a kind of interesting phenomenon that people actually outsource their private knowledge, and they trust the service providers. I think we should be careful about it, really more careful about it. Yes, but this is from the technical point of view. But this is one way how we could design systems. Actually, we could do it exactly in this way: that each software agent. Software entity knows about itself, and then knows about the location where the knowledge is stored, the rest of the knowledge. So this is actually a choice for architecture. Yes.
It's like a designing principle.
Yes. Yeah. Design exactly. Design principle. It's one pattern. A pattern is the word, because when it comes to architecture, then we often need to decide between different patterns. Like yesterday, I talked about peer-to-peer systems on one hand and client-server systems on the other hand, and then I mentioned that there are many possible patterns in between. So, and this is that you mentioned is one of such possible patterns. Yep. So, any other questions? For discussion, or in general, not just about these represent knowledge models, but just in general about this course. Has it all been reasonably clear so far, or kind of too technical? Clear or too technical? Yes, a bit technical, yes, especially I think yesterday and today. Yeah. Yes. But we need to tackle with those issues when we come to designing software parts of our system. As I said yesterday, the social component is enormously important, but it is not just about the social component, but we always need some technical components, the software agents or some other kinds of software components or hardware, but we need it. So any other comments? What I'm talking is not just about distributed systems, but it also applies to all kinds of systems, because even if we deal with the centralized systems, then we need to actually decide the functional subparts. That's another thing to be actually to be picked out from this course. It's always important to also to divide your solution into functionally coherent subparts.
So just a question.
Yes.
Could you just clarify, just by a practical example?
Yes.
What's the difference between domain model and organizational model? What types of
you mean domain model and organization model? Do you mean? because
we found that we have created organizational model, but we have created
did you mean acquaintance model maybe, or because organization model is about representing relationships between the roles. What we did, we actually we started on Monday with modeling goals. We actually modeled the purpose of your product idea, and that purpose should be aligned with value proposition. Then we divided that purpose, that main goal, into functional sub-goals. We attached to those functional sub-goals appropriate quality goals. And then what we did, we attached roles to appropriate goals. The meaning was that if a role is attached to a goal, this means that that role is required for achieving the goal. So this was the meaning here. Then the next thing, we represented relationships between roles. Remember, there were essentially 4 kinds of relationships. One role is controlled by the other one. Like I am in the role of lecturer, I am controlled by the role of manager, and the role of manager is played by our vice rector Alar Kolk here. And we have peer-to-peer relationships, like you in your groups. Within your groups, you have peer-to-peer relationship between each other. And then we had a benevolence relationship. That is a typical relationship between a customer and service provider, because a service provider usually satisfies a request by the customer, but in some cases may also refuse. So this is why we use the benevolence relationship. So this is organization model. So, and that I think you created yesterday the organization model, yeah. And but then after that we decided agent types, or we mapped roles to agent types according to some principles I explained yesterday, like coherence. There were some principles according to which we decided if we should map several roles to one agent type or one role to several agent types. And then we created acquaintances between these agent types, which represent interaction pathways. And that acquaintances are actually, they are based on organization models. Because you get an idea for your acquaintance model from the organization model. So this is the idea. But one is between roles, another one is between agents. But we have mapped roles to agent types. This means that we also can easily map actually our relationships between roles to acquaintances between agents. Because if for example I am controlled by my boss here, then obviously there is an interaction pathway between us, because we need to interact. How else can Mr. Alar Kolk control me? We need to interact now and then, which we have done. So this is did this answer your question?
The domain model we have presented yesterday.
No, acquaintance model yesterday. But domain model is different. A domain model is deciding the units of units of knowledge to be represented in our system, and then also representing the relationships between these units of knowledge. Like for example, relation. Well, this is not the best example for relationships. Maybe like here, friend list consists of friends. So these are 2 different units of knowledge, and this consists of is a relationship between them. So this is domain knowledge.
Can you give us an example in the smart house?
Yes.
An example of a domain.
In a smart house, yeah, example. Well, for example, you have a user or you have owner, excuse me, owner profile, and then you have that is represented as one domain entity, owner profile, and then you have and as another entity is information about, let's say it's one entity, information about the local environment in the house. And then there is a relationship between them, because they need to match If the owner prefers temperatures within the range 18 to 20, for example, then this has to match the owner profile. So there's obviously a link between this owner profile on one hand and the entity describing the local environment on the other hand. And then furthermore, there is a relationship between the entity describing local environment and entity describing external environment, because they need to match each other as well. If it's cold outside, then I mean you need to actually heat, and if it's warm, you need to cool down. So just relate these entities to each other. This is the meaning of a domain model. Yep. Okay. So now we have come to an interesting 1 hour or so, where we will hear from the representative of Google.